Good morning, everyone. Today we are going to discuss about the aerospace structural dynamics, which is under this UG program 20 regulation. So in this course, we are giving this first theory of vibration as a basics. So first class, we are going to discuss about the outcome based education. So today, my name is Shiva Krishna. I am from Institute of Aeronautical Engineering, Hyderabad. So we are going to see about this, what is this course and how it will be useful for the final year people, and how it will be useful for the project wise, and how it will be useful for the career wise. We're going to see in detail. So in this first, the overview of this course will be the first, it is a mechanical structure and susceptible vibrations, that is periodic change in physical state to this motions. So whatever the physical state it is there, we can able to model it into this mathematical model. So the mechanical structure and system that will be susceptible for vibration, that is periodic changes in the physical state, and vibration that can be both hindrance and benefits of the mechanics. And the objective of this course is to learn how to treat vibration phenomena by transforming the physical model into this mathematical model. So here it is the given overview, that is we need to be convert that whatever the physical model is given, that need to be converted into this mathematical model, and we can able to solve it the physical model by mathematical model by using a formulas. What are the formulas we can use for this, like Newton's second law, energy principles, and dynamic motions, and everything we can able to discuss into this course. So in this, there is a using appropriate mathematical formula operations and find the response and analyze the response of the bring it to this physical concept. So here it is the wherever the model is given, we need to be converted into the mathematical problem, and then we need to be find the response and natural frequency of the particular physical model, right? So this course also provides an introductory level to this aeroelasticity. There is a provides an introductory level to this knowledge of theoretical and experimental foundation for this aeroelasticity. So this aeroelasticity, which will be deals with the aerodynamics and structures, as well as there is a flight mechanics. So in these three, we can able to combine together. We can able to learn how the aeroplane will be going to this aerodynamically performance and structures and flight mechanics that will be given some vibrations into this. So vibration, when the flight is moving with the some higher velocities, so there will be sudden vibration changes will be going to be occur. So how to reduce that vibrations and how to observe the minimum vibration and damage to the system, we can able to decrease without catastrophic failure. So that we can able to learn into this theory of vibration and structural dynamics. So it is basically for the mechanicals people, we will be including all this theory of mechanics as well as structural dynamics, and for the fifth model we can able to go for this aeroelasticity basic introductions. So in this course, what is the student going to be try to learn? There will be formulate the mathematical models of a problem vibrating using of Newton's second law or energy principles. We know that already. What is the Newton's second law? Is nothing but F equals to ma, which is for the any simple harmonic motion or else the pendulum which is given, we can able to convert that physical model into this Newton's formula. We can able to solve what is the response and what is the natural frequency, what is the particular dynamic systems into this rotation motion or linear motion or transition motion. We can able to change and we can able to reduce a particular motion into this, where the lowest minimum observability is there for this particular system, we can able to change it into this particular formulas. We can able to learn this first outcome. So second objective, determine the complete solution to this model mathematical vibration phenomenon. So wherever the vibration is going to be occur, so we can able to model that particular problems, and we can able to determine the complete solution to this natural frequencies and response of this system. So we know that there is a, in every physical nature there will be some vibration. So like earthquakes, or else there will be a motion for the water flowing, or else there will be a dropping of particular seeds, or else fruits. So there will be some vibration will be going to be come within every engines, or else for the if you say that there is a lights, or else there will be some um sounds, there will be some vibration will be going to come. So we can need to be make it that determine the complete solution for this mathematical models. Okay, there will be mechanical models we can able to learn more, because we are concentrating on this mechanical as well as in this aerospace systems. So in this mechanical vibrations we can learn about this, what are the engines are there and how the propulsion systems are there. So once if there is a starting of the engine, you may observe like while you're traveling cars, or else in the bikes or cars, planes. So if you turn on the ignition, like giving the key, there will be a vibration of this particular engine will be going to come. Nowadays electricals are came, so in that there is no vibration will be going to be observed mostly, because in that there is a vibration free motion, vibration free elements has been added. You may observe there is a most of the vibration has been reduced into this automobiles industries because of this electrically generated power output, right? So all these things we need to be designed. So how it will be, we need to be converting that into the mechanical to this electrical system. We have been converted into like electrical propulsion as we see in that. So in this design mechanical system that has been desirable vibration behavior. So the vibration behavior we need to be reduced as much as possible, and we can make the particular systems into this more effective way, as well as it can be able to give the longer life. Once the vibration is giving less, then we can able to make that into this longer life. So once the longer life is came, then we can able to proceed for this higher profits. Like once you having the higher life, then we cannot able to replace many times, right? So that will be the under one of the profits only. Otherwise there will be no need to be go for this maintenance. So that will be also be one of the profit. So vibration behavior we need to be reduced into this design conditions, and assess the underlying assumptions. There is some assumptions are there in this aeroelasticity. So we need to be more concentrating on this aeroelasticity problems in the future. So because we are studying with this space structural dynamics, aerospace structural dynamics. So that is the basics we can able to learn into this aeroelasticity. As we know that there is a vibration, structures, aerodynamics and propulsion and flight mechanics which will be included into this aeroelasticity analysis. So like fixed wing as well as rotary wing aerospace vehicle structures and systems, we need to be learn into this particular outcome objectives. So as we seen that there is a objectives we can able to learn morely, like how to convert the physical model into this mathematical model, and how to determine the particular solutions into this, like a response and natural frequency and length and what is the mass, all those things we can able to determine particular solutions into this mechanical analysis, and how we can able to reduce into this vibrations into the particular dynamics into this particular system. Like we have said, like electrical propulsion is came from this space propulsion only. So once we change it into this particular vibration systems into some design particular point of view, like vehicles moved from IC engines to this electrical propulsion, then the vibration has been reduced more and drastically changes the vibration into this. Like that, there is a alternative solutions we need to be add, or else there is a design changes we need to be improved into this thought. And after that, there is a aeroelasticity problems are mostly we are going to be concentrate on this space structural dynamics as a aeroelasticity level. So we need to be go for this fixed wing, rotary wing. Rotary wing means there is a helicopters, and there is a drones. Those are future technologies. So we need to be concentrating on this fixed wing. There is a conventional one. So conventional one, we are having the fixed wing like a cantilever beam. We can able to say in that there is a high velocity. If you flow, there is a fluttering is going to come, or else there will be some. Once there is a turbulence, we can able to see there is a vibrations inside the cabin. Also, we can able to see all those things. We can able to learn and we can able to decrease into this particular system, and that is the course objectives. So now once we studied all these courses, what is the student can able to learn? So in this, apply the principles of the mechanical vibrations, like such as a Newton's second law, principle of conservation of energy, and mathematical models for the obtaining this their governing equations of motions. So we need to know that what is the governing motions. Like F equals to ma, we know to that there is a Newton's second law, and summation of forces equals to 0 in horizontal and vertical, right? So there is a horizontal forces and horizontal vertical moments will be going to there is a governing equations, and how to analyze the mathematical model to the 2 degrees of freedom. So first we need to learn about the single degrees of freedom, and we can able to learn how the spring and how the mass will be behaves under 2 different ways. Like force, if it is applied in 2 different columns or 2 different rotary motions and 2 different ways. So we can able to learn about this spring mass system in 2 degrees of freedom. There is a single degrees of freedom, multi degrees of freedom, and 2 degrees of freedom. We can able to learn it deeply in coming chapters. So first we can able to learn about how to analyze the particular systems, and we can able to solve natural frequency of the system and mode shapes and multi degrees of freedom. As we saw that there is a 2 degrees of freedom and 3 degrees of freedom, and multi degrees of freedom is there, like different attachments if it is attached on this particular things. So we can able to learn about this, how to solve the natural frequencies. What is the natural frequency and what is the mode shapes, what is the dynamic response. All those definitions will be going to learn in future. Though that is, we can able to learn about the natural frequency. You may already learn about this concept about these 9th to 12th classes. If you don't know, please go and read about these natural frequencies and mode shapes. Okay, that is the basics of this linear mechanics only. Okay, and apply theoretical and numerical procedures for this, predicting this dynamic response of the continuous structure systems under the most of the reversing loading conditions. So we know that there is a most of the structures, continuous structures, right? Dynamic response we can able to learn. What is the dynamic response? Like time changes. Once the time changes, or else day by day changes, and temperature changes, or pressure changes, variation changes, velocity changes, that will be called as dynamic responses. Once there is a temperature change, so that can be able to behave like a different way, and again there will be time changes and pressure changes, and once there is a season change also, there will be different response will be going to come from the same material. So that will be called as a theoretical numerical procedure for this dynamic response. So once the same thing we can able to change into the different weather conditions or else pressure conditions, that will be behaves in a different ways. So how to change that also we can able to learn into this application point of view, and formulate the static error elasticity problems, such as typical sections like a wing divergence and further sections like in the ball applications. So there is a future scope is there for this particular vibrations. So if you see there is a physical models like a wing structures and real world applications like UAVs as well as some helicopters and rotary wing systems, and coming future vehicles that will be under electrical propulsion or else plasma, or else there will be some another way like a lithium batteries are came right now. So it may be fusion technology is going to be coming in future. So then there is a vibration free and aerodynamic situations we need to be learned about this. All these things we can able to solve and formulate into this course objectives. So once the student passed out this course, he can able to apply the physical models into dynamic models, physical models into mathematical models, and he can able to analyze the particular systems in a single degree, multi degree, and 2 degrees problems, and we can able to solve this natural frequency and Mohr shapes and everything, and apply theoretical numerical problems into the dynamic response. How if there is a multi-degree freedom, a single degree of freedom, if it is having temperature changes, pressure changes, or else any other changes, if it is comes into this particular things, so we can able to analyze the particular time, and we can able to formulate the future objectives, like what are the model, like wings if it is there, and sections is there. All those things we can able to analyze and predict what is the motion, what is the dynamic response of the particular system, and how we can reduce the harmonic motions or else longitudinal motions we can able to reduce. All those things we can able to formulate into this as a course outcomes, right? So into this first chapter, theory of vibrations, so we can able to see about the single degrees of freedom for the linear systems. So we need to know about this linear system is nothing but once there is a time and load, if it is applied, there is a same response is going to be increased linearly, it is going to be varies, so that is called as a linear system, right? Okay, so in this course we need to learn about this, what is the introduction to this theory of vibration and equation of motion, that is the F equals to ma, conservation of energy, okay, all those things we can able to learn into this evolution of wave. And what is the free vibration, what is the natural frequencies, all those things we can able to learn into this. What is the free vibration, we can able to learn this naturally, and which is not giving any force from the outside. So which is not giving from any force from the outside, we can call it as a natural frequencies, free vibrations and natural frequencies. And harmonic excitation, impulse excitation, and step excitation, and periodic excitation, that we can able to solve it from this Fourier series and Fourier transformation and transverse function. There is a Laplace transfer function also we can able to learn into this particular chapter 1, which is under single degrees of freedom. So first we need to learn about the what is the vibration things. So what is the vibration? So introduction to this theory of vibration, but in this mechanics we know that there is a solid mechanics is the basics of this particular chapters, and as well as the structural analysis. So into this mechanical vibration or structural dynamics, there is a broad field of engineering and applied mechanics. So applied mechanics, you may know that there is a, in physics there is a second part of this particular physics, we can able to know that there is a applied mechanics, right? In this engineering mechanics there is a applied physics also, applied mechanics will be going to come. And what is the mechanics is nothing, one of the oldest discipline of the engineering that will be having field of deals with the action of forces and or environmental effect of the body, how the body will be reacted under these forces. So when there is a forces, how the dynamic response and how there is a body will be going to see that. In this course there is a solid mechanics, we can able to see what is the statics, and what is in this the main courses on this particular engineering mechanics, we can able to say there is a statics is nothing but solid mechanics. If we said that this will be called as statics. In this no response will becomes, in this there is no response will becomes, and no reactions, no response and no reactions will be going to come, that is called as static. Like a hill is there or else mountain is there, right? So if there is a number of forces also, there will be no reactions you will be going to see into this particular system, that is called as a statics. It is called hills, one of the examples, okay, right? There is a hills, if you see there is a static, there is no response will be going to come. And engineering materials, so mechanical materials, there will be, if there is a behavior we can able to change by temperature, pressure and time and environmental condition. Environmental conditions, temperature, pressure, time, environmental conditions, we can able to change. That is the mechanics of these materials. Like it may be a plastics and aluminium and steel and cast iron, all those things we have different materials, right? So in this cast iron, mild steel, and aluminum and titanium and different materials, how it behaves into this like a different materials. And dynamics is nothing but once there is a temperature changes or else time changes, we can able to vary with this time changes and material changes, we can able to call it as a dynamic changes. And kinematics is nothing but once if we are having the motion, once we are having the motion, then we can able to call it as a kinematics. Once because there is a static is nothing but there is a potential energy, we can able to say there is a statics. So once it is a dynamics nothing but there is a motion should be there. In this motion, how the materials or else behavior of the body will be going to changes, we're going to see about this into this kinematics. So in this last one is the engineering mechanics or else mechanical vibrations. So in this all mechanics, broad mechanics engineering, there is a statics and dynamics and materials and kinematics and vibrations. So we need to be focusing on these vibrations right now. So we have been studied all those things in this engineering mechanics. Engineering mechanics we have been studied, and material science we have been studied into this like in the second year, and dynamics and kinematics we have been studied into this third year, and now it is in the under mechanical vibrations that is under fourth year. So now in any field of engineering that can be represented in the following way, like if there is a system is there, if we give the input to the system, then it will be going to give the compulsory as a output. Like if we say there is a tree is there, and if we give the water and air and nutritions, if there is a given, then it will be used as a fruit, right? It will be used as a fruit. So that is a one of the natural system. If we give the air and soil and water as an example, and there will be fruit will be going to get it as a output, right? That is a nature, we can able to say that the air if we given and water is given to the tree, then it will be going to become as a output. As a input is nothing but one of the air and soil and water if it is given, then output is nothing but one of the fruit. So in this there is a study of mechanics will be going to say there is a only difference between different assumptions, there is a nature of these components. Once there is a component like in this mass and dashboard and K. So in this component there is a mass and spring system and dashboard system. There is a cushioning system, we can able to say that is. So in this MCK, what we going to see into this engineering mechanics. So engineering mechanics will be going to study. There is a physics as well as there is a biology, we can able to say in this as a physics air, right? Physics and chemistry we can able to change into this. So like statics, what is meant by statics here? In this statics, as we said, there is a hill. There is a hill if it is there, and if we give any forces on that P, if we give any forces or loads, if we give that, then there is no reaction is going to be happens. It is like nothing but one of the rigid body. We cannot able to deform into this. Deformation nothing but once it is there into this, once if we give the forces, then it can able to move towards the x distance like this, x1 one position and 2 position. So if you give the force, then it can able to move to this first place to second place is nothing but it is a not a static system, it's a dynamic system we can able to call it, right? So in this there is a forces, F is given, there is a system. A is nothing but a forces or load with a time dependent. Like as we said, there is a time dependent like a pressure, variables and time difference will be going to be changes. And assume the system is to be rigid like a particles. Into this, all the system is going to be, there is no reaction is going to be happens into this. There is no deformation is going to be happening to this. There is no elasticity varying in the loads also not going to be happening to this. Like a material is going to be constant throughout the day or throughout the pressure is given, right? That is called as stone, like a stone or hill, right? there is a stone or a hill, we can able to say there is a pressure is given. And if there is a rigid body, we can able to say, for example of this particular system is given like this. So the system of forces is nothing but reaction forces. Reaction forces is nothing but for this. So R1, R2 are the reaction forces. There is no reaction forces into this particular statics forces. Because of the statics, the rigid body of the system, it cannot able to have an observed energy. As we said, there is no deformation, then there is no observation of energy, and it cannot be able to deform simply by transferring the whole input to this supports. So what are the forces it is given, though, that can be able to give transfer it to this supports directly. Then there is no reaction forces will not be there into this. There is no reactions, there is no deformation, and it cannot able to move from one place to another place also. There is nothing but a rigid body conditions, right? So which is rigid body condition? Like if you are having the any mountain, we cannot able to push it directly. And like if you are going to give a higher pressure also, there will be some of the particular portions we can able to destroy. Like that, like higher forces, higher pressure we can able to say. That is called as a static forces. And in these statics also there will be some mechanics of materials is there. As we said, there is a branch is having some of these statics and mechanics. Statics we have been seeing there is no reaction will be going to come, and near mechanical materials and dynamics and kinematics. So what is this materials of the mechanics of the materials? So in this there is a forces going to be changes. The forces is going to be changes, like in the time dependent one, it can be able to go for this like pressure, temperature variations and velocity changes. We can able to say there is a load, there is a pressure, temperature, velocity, that will be called as into this time dependent. Okay, in this time dependent we can able to say there is a pressure, temperature, forces also. Forces are loads, right? The forces and loads we can able to say that is it. Okay, and assume the system can be flexible, that is a deformable, and it can be elasticity. It can be give the elasticity. Like into these materials, if we give the load, we give the P and L, elongation of length we can able to say this. So once you give the increasing of load, then there will be deformation also will be going to change. Yes, deformation also going to be changes, like a change in length. So that it will be gives the static forces. So mechanics we can give us materials. There is the forces of internal forces, forces of internal force. There is the shear or moment of inside the beam we can able to see, and deformation we can able to call as a, so stress and strains we can able to produce into this mechanical materials. Like solid mechanics, we see there is a mechanics. In that again, there is a materials will be going to be concentrated. Like material, it may be aluminium or cast iron, steel. All those systems we can able to see into this particular materials, right? So we can able to see there is a stresses. Stresses is nothing but load by area. Load by area, and strain is nothing but that is a stress. Sorry, strain is nothing but change in length by original length. Change in length by original length we can able to call it as a strains. There is no units. In this stresses, newtons per mm square, right? Newtons per mm square will be going to happen into this stresses by strains. And dynamics, what is meant by dynamics? We can able to say there is a time dependent and assumed to be system is going to be rigid, body is rigid, and it may be time dependent force also. That will be velocity, acceleration, etc. We can able to see into this dynamics. So all these dynamics we can able to learn into this flight dynamics. That is dynamics, aerodynamics, and basic is the fluid dynamics. Right? Fluid dynamics. All these dynamics we have been studied as a basics, as a second semester in second year. right? In second year, there is a in the third year. So flight mechanics and aerodynamics, all those things, aerodynamics, we can able to see in that there is a dynamics behavior. Once there is a velocity changes, once there is a physical changes like appearance of this particular angle if we change, then how it will behave. And once there is the acceleration is changed, once there is the velocity is changes, how the motion will be going to changes. All those things we have been studied with this fluid dynamics and flight dynamics and aerodynamics. Like the forces, it may be time dependent. Assumed system is to be rigid and time dependent, like velocities and pressure, temperature, all those things we can able to vary into this dynamics of these particular bodies, right? We have been seeing about this first, like a statics we have been seeing, the mechanics of material seen, and dynamics we have seen, and what is meant by kinematics and what is meant by vibrations we're going to see about this into this next topics. So in this kinematics, what is meant by kinematics? There should be some motions or displacement should be there. Like into this, there is an input motion should be there. The motion, if it is there, call it as a compulsory. It is a dynamic. Once there is a flow, it should be a compulsory dynamics, or else the movement. If there is a movement, it is called as a compulsory as a dynamics, right? So it is assumed to be system is rigid, and output motion, that may be a position, like it may be changes from one place to another place, and displacement like a change in length, and velocity changes, acceleration, velocity changes and acceleration. All these things we can able to include into this kinematics. What is meant by kinematics is nothing but there is a change of energy from one place to another place, or else deformation will be going to be happens through this behavior of this motion, right? If there is a motion or else flow, then there will be continuously changing of those motions, or deformation will be going to be happen into this. Like water flow into this dam, like a water flow into this dam, and this is the water, okay, and once you open the gate, then there is a flow, or motion is going to be happens, right? So there is a compulsory, there should be a motion should be there, then it will be called as a kinematics. Once the behavior we can able to change this into this, like in the flow or motion there is a changes, then we can able to concentrate on this kinematics of this body. So it may be a static, or it may be a rigid body, or the materials of the mechanics, and mechanical vibrations. What is meant by mechanical vibration here? Particularly into our particular chapters or subject, it is related to this mechanical vibrations. It is a basics from this engineering, mechanical, physics, right? So in this, there is a forces or any other time dependent phenomena is going to be happens, and that can be caused by this change of systems. Like example, displacement, the forces that can be desirable like engines, or else undesirable like earthquakes. As we said, there is a natural frequencies and forced frequencies, right? In this called as it is the forced vibrations, because we have been giving this input, and this is a natural vibrations. So that may be flexible bodies. So that means that there is a whole force or energy that not going to be happens, going to be outside of the gate of this, some of the part of the observed by the systems, like a dampings. So what is meant by damping here? So damping is a energy observing system. Energy observer. Energy observer called as damping. And flexible body inertia and elastic and assumptions will be going to see this. So there will be a forces in displacement and strains and stresses. As we know, there is a displacement and strains we have been seen already. What is meant by displacement and stresses and strains? We have already seen, right? So in this, what we need to be going to see in this particular courses. So if there is a system, there should be some input and output should be comes. Once you give the input, there should be compulsory, there should be some output. Like if you give the forces or displacement, there is a this stresses and strain is going to be happens. So like a spring mass system, if you consider spring mass system is considered, if you give the F, that is the force, if you give the force to this particular spring mass system, then it may be changes to this towards the next position. There is a x distance has been moved, so it is called as mass. Okay, again there is a displacement, we can call it as a displacement, right? Displacement or force that will be gives the stresses and strains is the nothing but output. So in this spring mass system, there is a mechanical vibration of this course. It is possible to set up some mathematical models that has been of these elements, like a physical models to this mathematical model, like a spring mass system. We can able to call it as MKC. So what is M is nothing but mass, and K is nothing but spring, C is nothing but dashboard or else observer. We know that there is a observer, there is a damping system, we can call it as. In this, like a damping is nothing but a washer or else spring system that can be gives a reduce of these vibrations, right? So in this, the formulation of mechanical vibrations by using of this ordinary differential equations, ODE. You may know that how we can able to utilize our mathematical models, like a partial differential methods, or else where we can be able to use in the physical models, right? So once we are having this ODE, ordinary differential equations, as a basics, we can able to learn how the vibration we can able to control, and we can able to change the system into this single degree of freedom, multi degrees of freedom, and whole length we can able to convert, right? So there are two ways of the solving of this particular problems into this. There is a Laplace transformation, or as direct formulations or integrations. Direct formulation we can able to get it by partial differentiation d by degrees of freedom, sorry, d ODE. Ordinary differential equations we can able to like in the d by dx time change, right? D by dx we can able to change, and by integrating from 0 to k, 0 to n, or k, n, like that physical models we can able to change. So it can be a Laplace system as a system. One of the example we can able to say there is a direct integral method or Laplace system we can able to say from 1 y to y double dash to y, we can able to get it by using of Laplace transformation. So we give the input as a L, and by using of Laplace transformation it can be gives the output as Laplace inverse of this S, Laplace inverse of this Laplace S. So we can able to go for this integration, that will be also same as this, like y double dash is there, like that y double dash is nothing but dy by dx is dy by dx, d square by dy square, right? So that will be called as d double dash, and we can able to give this as an input of y, right? Output of y. So rather by solving this very complicated integrals, we can able to go for this Laplace methods, or as first mapped equation to the another domain also we can able to get it, and then we can able to go for this inverse of mapping and so solve the solutions. So in this, there is a in this course we can able to deal with some of these simple second order differential equations, so that we can able to go for this direct approach for the solving of these problems, or as we can go for this working with the complex numbers of this course also, and the real numbers that we have in dimension, two dimensions, like a real dimensions and imaginary dimensions. If we say there is a z is there, so we can able to see there is a x distance. X distance is nothing but if we say there is a 1 meter, okay, 1 mm if we say there is a, and imaginary there is a I of y. We cannot able to predict that how much distance is there into this height. So into this vertically it is nothing but I y, right? Iy is nothing but it is the imaginary distance, we can able to say imaginary distance, and some of the other numbers having some of imaginary number parts we can able to say into this integration, like in this particular system we can able to say. As an example, we can able to see the complex algebra has been one operations like summations and subtractions. So if there is a z1, we can able to solve it by using of z1 equals to x1 plus I of y1, and Z2 we can able to say there is a X2 I of Y2, right? And ZT transformation we can able to say there is a Z plus 1, Z1 plus Z1. We can able to write it as in the X1 X2 plus imaginaries Y1 1 Y2s. So we are adding and summation, subtraction we can able to say there is a plus or minus we can able to say into this same, right? Plus or minus we can able to say there is the same thing will be going to be happens into this by adding the real numbers one side and adding the two imaginary numbers at the one side. They will be given as a summation for this particular problem. And multiplication for this type of questions we can able to say there is a I equals to under root of 1, or else I square we can able to say there is a I2 is nothing but y, and we can able to write it as a I equals to as a minus under root 1 under root minus under root of minus 1. So we can able to write it as in this minus 1. I we can able to write it in terms of minus 1. And Z transformation we can able to write it as in this multiplication as nothing but Z1 into Z2. As we know there is a Z1 and Z2. If there is a Z1, Z2 has been given, how to multiply this one? You may already learn all these things into this intermediate levels, right? So just it is a basic for this. So again we are going to change this as a into this x1 y1, all this input we are going to substitute here, and again x2 y2 we are going to substitute here. And once if you want to multiply, there is a multiplication symbol, we can able to multiply as a x1 x2. So x1 multiplied by x2, and again there is a y1 multiplied by this y2. So you can see there is a x1 y1, we can able to see there is a y1 y2 plus there is a plus or minus, same thing will be going to happen. So in this minus is there, it's a multiplication. So plus imaginary numbers is there, right? So once imaginary number is there, once again we are going to include with this 2 times. So y into x1, y2 into x2, like there is a multiplication numbers we can able to form into this, right? And division also same, we can able to change it like a z transformation equals to z1 by z2. Z1 by z2 we can able to multiply in terms of zt into 2. We can able to transfer into this z2 into 2, that is a multiplication or a transfer equals to z1. So in this form zt we can able to form into this as the above formula. We can able to change the same thing. So the complex numbers equation we can able to go for this equal imaginary person equations. So all these things as the basics we are going to skip into this because there is a mathematical problems we're going to check it all those things as a basics. So now we can able to see there is a r of cos x. There is a z transformation. You can see there is a z is a point where there is a radius is there. So r cos of theta and sin theta is there. R cos theta plus sin theta is there. Another way we can go for this analog or real problems into this polar coordinates. The polar coordinate is nothing but not in this rectangular. It's a Cartesian coordinates we can able to say. Cartesian coordinates, and if there is a circle and pipe is there, so that will be called as a polar coordinates, like in the spherical body also, like in ball bearings and tubes and all these things, we can able to say there is a coordinates. Okay, in this you can able to say there is a r and there is a theta and length. Theta and length we can go to calculate. So r theta l is nothing but basic polar equations forms. So here there is a y column we are having the r sin theta, and x column we are having the r cos theta. So z can be written in terms of r equals z equals to is nothing but at this particular point we can able to say there is a r into the radius into e to the power of I theta. Here is nothing but e into I theta we have been taking for this I coordinates, right? So complex conjugate also we are having this minus z star. You can check this, there is a z1 in terms of negative action will be there. So in this you can check this, there is a negative and positive axis is there. Once it is given the conjugate complex forms. So all those things we have been seeing in this physics or engineering, intermediate second year. Second year problems, all those things we have been seeing for this first year and second year for the intermediate level. intermediate level or first polytechnic level also they can be completed all these things first year and second year intermediate levels. Then go for this brushing of these particular problems. We can able to solve these particular problems into these coming chapters. So coming to this particular vibration, what is meant by objective of this? So objective of this mechanical vibration is to want to be analyze the and understanding the behavior of a system under the actions of a desirable undesirable motions. Desirable motions means what we require to be like a output, like if you want to turn into 90 degrees or else 20 degrees if you want to turn onto this shaft, this is called as desirable solution. And if it is going to be changes into this 30 degrees or 40 degrees, that is called as undesirable motion. Like if you are giving the pen or else a screw or else a tap, if it is given, okay, if you want to change the particular rotation, that will be called as a desirable motion. So if we are stopping the vehicle in a particular distance, so by using of these brakes, right? So if it is not connected particularly, then it will be having some extra motion, right? That is called as a braking skip, right? So if there is a bike or car, if you want to stop the particular line, then it will be under this desirable condition. And if there is a missing of this particular line, that is called as undesirable motions. So in this vibration has an effective way, that is the eliminate of this particular system. So in these vibrations, we focus on the system that will be having the importance of this part. We can able to understand how the model will be present under these forces. So system can be system is maybe simple or maybe complex. So for the example of the system, will be having engineer having simply system having this forces is time. Force is a time. Okay, force is a time dependent system, and system is having some element inherent for this particular system for the physical structures, and any physical structure in general are more than one or three members major inherent properties. There is a characteristics that will be basically having some system made upon or capable of doing all these order by resisting of these forces. So the properties of physical structure will be having general more than three inherent properties or characteristics. So what is meant by properties or characteristics here? So every system in the nature, there will be having some particular properties. Like if we say there is a thread, or else there is a ball, or else a bat. If we say there is a anything, or a car, any vehicle, if we say there is a compulsory, there will be mass and elasticity and energy absorbing materials, energy absorbing mass. So here it is, there is a mass. If there is a vehicle, if we call it the complete body is nothing but mass, and elasticity is nothing but once you give the motion, there will be some deformation is going to happen. That is called as elasticity. And energy absorption, like a cushioning, all those things we can able to call it as a energy absorption. For this inertia of the system, which is resulting on this action of forces, will be moved on these certain directions. And system are a structure that has the ability to resist motion. This resistance can be comes into these two distinct ways. Like in the elasticity, like if you give the input like a disturbances, force, displacement, acceleration system, if you're given, there will be some response will be going to come. That is called as the output, right? So in this displacement, if you give, then disturbance like a force, if you give, there is a change in length will be going to come. And displacement, if you give, then there is a motion of this x1 to x2 position is going to come. Time variation, acceleration, if you give, there is a particular output is going to come at this particular output side, right? So into this mass, what is meant by mass here? There is a inertial system that will be having result of this action of these forces of moves and certain directions. So in this, for the mass, for some inertia forces of the system that will be having, which will be having result with the action of these forces that will move certain direction, right? If there is a mass and if you give the force, then it will be going to move towards x distance. So there is a m. This dotted means it is a after the giving this force, after giving the force, then there is a movement after that, right? And velocity, which is nothing but structure resistance, is going to be through some of the deformation and bending reaction occurring to the action of the forces, and like RS, energy absorption of system, that will be go for the structure resistance imposed on this motion, RS forces by the trying to dissipate the effect of this action or dissipating the energy that can be resist the motion. So there is a energy absorption and elasticity, mass. As we said, there is a m is given and spring mass system is given, right? and if you give the F as a force towards the end, force towards this end, and there will be some resistance is going to be happens. Resistance is going to be happen. That is called as absorption. Resistance is going to be happen. That is called as absorption. Like trying to keep on this moving the same position. Trying to keep it on the same position. So that it will be called as a absorption, energy absorption. That is called as, once there is a displacement up to when the force is giving, then there is a displacement is going to be comes, and that is called as a elasticity. If you're giving the trying to give the force, and it will be going to be comes into this picture, like in the deformation is going to be happens. Deformation is going to be happens, right? Load if you give, then there is a compulsory deformation is going to happen. That is called as under the elasticity condition. And the goal of the vibration analysis is to find the system that will be most appropriate mathematical model of the real or physical motion, physical structure in the mechanics, right? So in this idealization, we can able to go for this, making the logic of the assumption based of knowledge of physics structure. There is a defining some of the things that can be help us to develop proper mathematical models. So in the idealization, we can able to give the mathematical model, making some assumptions into this physical models to these mathematical models, and define some of the help to develop a proper mathematical models into this. So like disturbances, what are the disturbances will be going to come into this, like a forces certain terms of like in the behavior of the motion, and we are forces we can able to certain forms of behaviors, and motion that will be having some dealing with the two types of motion. There is a translation motion and rotary motion. As you see, there is a translation motion and there is a rotary motion. There is a rotary motion, right? There is a translation motor and rotary motion, that will be which is having the main difference between translation and rotary motors. We can able to see into this. So what is the difference between translation motion and rotary motion? The both having this talking about this masses and some of the motions. And in the translation motion, we are looking to this motion of the in terms of which they happening towards the center of the mass, which is towards the center of the mass will be going to be happens. The forces will be going to be comes towards the center of the mass, and the disturbances of the mass are as the way of mass distributed, or as inertia that will be having not so important of translation motion, while the rotational motion having this mass distribution super important. Because of this, in the rotational motion, there will be torsional is going to be happens. There is a torsional motion will be going to be happens, right? So that is called as a difference in this translation as well as rotary motion, right? So in this translation motion, there will be dealing with this mass, center of mass, and how the mass is impossible with this one point. And rotary motion dealing with this mass moment of inertia. We know that there is a moment of inertia will be going to come with this IR square, right? So there will be going to be changes into this AR square and IR square. We can able to change this into this particular rotary motions, right? Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.